Oceanography News. Welcome to D2 Oceanography and Marine Science News, Episode 6. Start out this episode with a throwback to 76 years ago. On February 6, 1949, Woods Hole Oceanographic Institution researchers arrived at the Arctic Research Laboratory in Point Barrow, Alaska, the northernmost point of the United States, to explore the potential for long-term oceanographic research. Seen in these photographs, William G. Metcalf and John F. Holmes spent the frigid months of February and March far north of the Arctic Circle, testing equipment, investigating facilities, and performing preliminary work. This initial expedition paved the way for future WHOI research at the poles. Today's scientists and engineers carry forward this spirit of exploration, building on decades of discoveries on the Arctic frontier. In follow-up to our last episode on dark oxygen, newsflash, photosynthetic organisms aren't the only source of oxygen on Earth. The presence of dark oxygen in places beyond the sun's reach has baffled scientists for some time. A recent study pinpointed one surprising source: metallic rocks found 13,000 feet below the ocean surface. But this phenomenon isn't limited to the ocean, and rocks aren't the only source. In 2023, Marine Biological Laboratory and WHOI scientists found oxygen in ancient groundwater in Canada, which they attributed to microbial activity. Relicanthus is a newfound species found at 4,100 meters in the Clarion-Clipperton zone. It lives on sponge stalks attached to polymetallic nodules that are of interest to the mining industry. Oxygen in unexpected places. Oxygen is hard to produce without continuous energy that comes from sunlight, but other scientists have also encountered unexpected oxygen molecules in remote, light-deprived places. Sweetman said that dark oxygen production may be a wider phenomenon that has been overlooked. Emil Ruff, a microbiologist at the MBL in Woods Hole, Massachusetts, detected oxygen in freshwater samples in Alberta, tens to hundreds of meters beneath the Canadian prairie. A finding he and co-authors from the University of Calgary and Woods Hole Oceanographic Institution reported in a study published in 2023, June. In some cases, the dark oxygen had been isolated from the atmosphere above ground for more than 40,000 years. If oxygen is not continuously being added to an environment by trees and plants, for example, it would eventually disappear. After 40,000 or 30,000 years separated from surface processes, there's no reason to really think that there should be any oxygen left, because oxygen is a yummy electron acceptor. It usually either chemically oxidizes or microbially oxidizes, Ruff said. So what is it doing there? Similar to Sweetman, Ruff said he first thought atmospheric oxygen had contaminated his samples, which were drawn from 14 groundwater aquifers. Given the age of the samples, any oxygen would have reacted with other substances long ago and disappeared. After patiently working in the lab and field, Ruff ultimately discovered that microbes in the water were producing oxygen. The microbes had apparently evolved an obscure but neat trick that allowed them to produce molecules in the absence of light. Through a series of chemical reactions, the microbes are able to break down soluble compounds called nitrates, molecules made of one nitrogen and two oxygen atoms, to produce molecular oxygen in a process known as dismutation. The microbes also had the ability to use the oxygen to consume methane in the water for energy. What's more, Ruff found that the quantity of oxygen produced was enough to sustain other oxygen-dependent microbial life in the groundwater. Quote, "Nature keeps surprising us," unquote, he said. Quote, "There are so many things that people have said, oh, this is impossible, and then later it turns out it's not," unquote. To investigate dark oxygen further, Ruff and his team traveled to a 3-kilometer deep, 9,500 foot deep mine in South Africa in August to sample water that had been trapped in the rock for 1.2 billion years. A team of scientists hunt for microbes at a study site in a 3-kilometer, 9,500 foot deep mine in South Africa. The researchers study brines isolated in the rock for 1.2 billion years that are teeming with life and are investigating how oxygen is produced in this ancient ecosystem. Scientists already knew the water in the mine contained oxygen molecules, but it's unclear how they were formed. Ruff and his colleagues are still studying the samples they took. They have two hypotheses as to how oxygen molecules might be produced, he said. The The site is mined for gold and uranium, a radioactive metal. Radiolysis, the splitting of water molecules through radioactivity, is one of the possible ways oxygen is produced without sunlight. Alternatively, the production of oxygen could involve microbes and processes similar to those rough found in Canada's groundwater. Sweetman said on Friday the new project would also seek to understand whether any microbial reactions played a role in dark oxygen production on the seafloor. In particular, the project will look into how hydrogen is released during the production of oxygen by the metallic nodules, and whether hydrogen was used as an energy source for communities of microbes detected in parts of the deep ocean. Quote, "We don't have the mechanism, I think, completely wrapped up yet and will need a lot of time to figure that out," unquote, he said. Ruff said he hoped to collaborate with Sweetman and other scientists involved in the dark oxygen research to understand how the chemical signature of the oxygen produced by seawater electrolysis differed from the produced by microbes or radiolysis. Dark oxygen in the search for extraterrestrial life. Officials at NASA are interested in the research on dark oxygen production because it could inform scientific understanding of how life might be sustained on other planets without direct sunlight, Sweetman said. The space agency wants to run experiments to understand the amount of energy required to potentially produce oxygen at higher pressures that occur on Enceladus and Europa, the icy moons of Saturn and Jupiter, respectively, he added. Those moons are among the targets for investigating the possibility of life. Deep-sea mining companies are aiming to mine the cobalt, nickel, copper, lithium, and manganese contained in the nodules for use in solar panels, electric car batteries, and other green technology. Some companies have taken issue with Sweetman's research. Critics say deep-sea mining could irrevocably damage the pristine underwater environment and that it could disrupt the way carbon is stored in the ocean, contributing to climate crisis. The metals company said that it had submitted a rebuttal to Nature Geoscience. The journal published the original research. The submission was undergoing peer review but has not been published yet, the company said. Sweetman said he was aware of the critical reaction and would respond, quote, through peer-reviewed channels, unquote. Quote, "We are completely convinced that this is an actual process going on at the seafloor," unquote, he said. Sweetman also said it was prudent to hold off exploiting resources on the seabed until the ecosystem was better understood. Amy Gartman, a research oceanographer and global marine minerals project chief at the U.S. Geological Survey's Pacific Coastal and Marine Science Center in Santa Cruz, California, said the USGS has not observed any electrical phenomena in ferromanganese nodules examined so far. She was not involved in either Sweetman's or Ruff's research. Quote, "Researchers are currently trying to replicate the phenomena reported by Sweetman and others," unquote, she said. Quote, "Scientific research is a process and it may be some time before a conclusive answer is reached," unquote. From the Schmidt Ocean Institute, did you ever have a day filled with meetings and problems and details to deal with? Question. Sometime around 1, you realize that breakfast and lunch passed, but you didn't eat. You are very hungry. For the next hour, you're brainless. Drifting through the afternoon, guided by the fog of hunger and the vague hope of sustenance, you stumble upon a box of half-eaten donuts in the break room and consume sugary snacks without thought. While this comb jelly is not a mindless zombie on a serious snacking mission, it lacks a central nervous system. With no brain, the jelly can sense its environment, but as Rick O'Connor at the University of Florida writes, quote, "Memory and thought is not high on their ability list," unquote. The jelly, also known as a ctenophore, has tentacles lined up with cells called cyanoblasts. These cells house a coiled harpoon possessing a drop of venom called a nematocyst, O'Connor says. They dangle their tentacles without thought until they happen upon their next meal. You can read more about the ancient jellies at the links provided in the description box. ROVs spotted this rainbow beauty during the Antarctic Climate Connections expedition. During this research cruise, an international science team is creating the first high-resolution maps of this region and studying the animals that dwell there. Understanding the lives of animals and organisms has important implications for conservation. When a population is isolated, the risk of extinction grows dramatically. Few places on Earth are as isolated as the seafloor in Antarctica. Sharing the discovery of a shipwreck we found with a Sea-Imagine sub in the Bahamas by accident. This was during a pilot training dive going down a wall around Nassau. we suddenly saw the outline of a bow, and to our surprise, an entire ship slowly came into view. The ship was at a depth of 250 meters and at a 60-degree angle, bow pointing up the slope. We found the name of the ship, the San Salvador II. Once we were back on deck, we quickly started searching online for details. Originally commissioned in 1955 under the name USCGC Cape Fox for the U.S. Coast Guard, the cutter was used for search and rescue and law enforcement. In 1989, the USCG decommissioned and transferred the vessel to the Royal Bahamas Defense Force, where it served under the most recent name San Salvador II until 1999. It sank during a storm following an engine fire, and fortunately there were no casualties.
San Salvador II. Shipwreck in the background.
I could have.
Ocean is changing and the seafood industry can't keep up. As the Gulf of Maine warms at record speeds, iconic New England species like cod and lobster are shifting north in search of colder waters. Fishermen say reduced yields, new limitations on catch sizes, and the misallocation of permits are putting the $20 billion industry in jeopardy. In New England, climate change is moving fast, the fishing industry is not. Amaru knows these waters. He's been a commercial fisherman for more than 50 years. No small feat in a tough industry, and his expert eyes sees the ocean changing. The most obvious shift, the water is warming and attracting different species of fish. Quote, nothing is weird anymore out here, unquote, he said. Quote, tropical is getting to be fairly common, unquote. The shifting species could bring new opportunities for fishermen, but the changes are coming so fast the industry is struggling to keep up. Scientists, regulators, and fishermen are all scrambling to adjust to a new reality. The New England seafood industry generates more than $20 billion in sales each year and employs more than 250,000 people. It's also embedded in the history and character of many coastal communities and the fabric of many families. Amaru's son and grandson are both full-time commercial fishermen. He worries about their futures. Amaru has a lot of concerns about the industry, convoluted regulations, the potential impact of offshore wind development, and a booming population of fish-eating seals. The climate change tops his list. The more we disrupt the climate, it's making it very difficult to make a living on traditional stocks, he said. The fish are just not here anymore. When familiar fish flee or die, the Gulf of Maine is warming faster than most of the world's oceans. As a result, iconic New England species like cod and lobster have shifted north or moved deeper into the ocean in search of colder water. But temperature is not the only change. Melting glaciers are altering ocean currents, weather patterns are shifting, and carbon dioxide dissolving into the ocean is making the water more acidic. All these factors affect different fish species in different ways, said John Hare, director of the Northeast Fisheries Science Center, the research arm of NOAA Fisheries. What surprised me the most was the magnitude of these changes, Hare said. Mostly these changes have been bad for New England fisheries, with many habitats vulnerable or in decline, and many fish populations shrinking. We had considered climate change as large-scale, somewhat slow-moving process, said Kate O'Keefe, executive director of New England Fishery Management Council. But we've seen some things change very quickly. Herring is one of the populations undergoing rapid changes. The species is key to ocean ecosystems, serving as food for other fish and birds. Herring are also important to fishermen who use them as bait. The herring, like many fish, face challenges in the changing ocean conditions. The most recent federal data suggested a precipitous population decline. Though scientists have not been able to pinpoint an exact cause, to address the decline, fishery managers recently proposed reducing the herring catch by 89%. Fishermen said the reduction would be devastating. Quote, are you crazy? Unquote, asked fisherman Daniel Phil at a council meeting in Gloucester last fall. Quote, that's decimation of the whole herring fleet, unquote. Mary Beth Tooley, who works for the fishing company O'Hara Corporation in Rockland, Maine, said the outfit will mothball its 2 herring boats for 2025. Quote, the amount of fish that's allocated is not enough to, quite frankly, pay your insurance to get away from the dock, unquote, said Tooley, who coordinates government affairs for the company. Like Amaru, Tooley said climate change tops the long list of challenges facing the fishing industry. The pace of change has been much faster than people had anticipated, Tooley said, and the pace of regulatory change is not fast. As a fishery manager, O'Keefe agrees regulators are struggling to keep pace with climate change. Managers, she said, have few tools to respond to sudden events like marine heat waves or die-offs. One example, sea scallops, New England's most valuable fishery. Scallops had a number of die-offs in recent years, likely associated with warmer water. So when surveyors spot an area with surprisingly large number of baby scallops, it's welcome news. Ideally, managers would place the area off limits to fishing and allow the scallops to mature, said O'Keefe, but a quick pivot isn't always an option. Perhaps even more frustrating, fishery managers can't always take advantage of climate shifts that could benefit the industry. Black sea bass is a prime example. The commercially valuable fish have been expanding north into New England waters, but while the fish are moving, the regulations are stuck. Since black sea bass were not historically abundant in New England, the fishery is managed by mid-Atlantic regulators. While some New England fishermen have permits to catch these, the lion's share of the quotas and permits remain trapped in the mid-Atlantic. Quote, what that means for us, not having any management authority over it, is that we don't have opportunities to harvest it, unquote, said O'Keefe. To adapt to climate change, she said the industry needs more options like flexible permits, ways to react too quickly to fish booms and die-offs, and the ability to land new fish that are coming in. Quote, it's a very high priority for us right now, unquote, said O'Keefe. As we see some of our traditional stocks declining or shifting north to Canada, we want to be able to take opportunities of stocks that are shifting into our waters. Addressing those shifting populations will be difficult, said Amaru. You're going to take something away from one region that may not want to give it up to another, he said. That's a challenge that the Fisheries Service, all the states as well as the federal government is working to try to solve, but it isn't easy. We can't wait a decade. Scientists and fishermen have a historically fraught relationship that may be changing, at least somewhat, as both groups recognize the value of each other. There's just a wealth of knowledge in the fishing community, said Glenn Gawarkowitz, a senior scientist at the Woods Hole Oceanographic Institution. He meets regularly with a group he affectionately calls the Squid Squad, a handful of scientists and squid fishermen trying to understand the dramatic changes they're seeing in the ocean. Some of these fishing families go back multiple generations, said Gawarkowicz. He said their detailed logs and collective memory are a necessary complement to scientific data, as both groups try to understand patterns that we haven't seen before. Another cooperative program called EMOLT outfits New England fishing boats with devices that collect data on water temperature and oxygen levels. NOAA's George Maynard, who runs the program, said it's popular among fishermen who hope the data can lead to more accurate ocean models. Biden administration poured hundreds of millions of dollars into NOAA fisheries for climate change efforts. This includes $15 million for more effective permitting and $40 million for the Climate, Ecosystem, and Fisheries Initiative to accelerate work linking NOAA's climate science to its assessment of fish stocks. It's unclear how these initiatives will fare under President-elect Donald Trump. While some money from Biden's Inflation Reduction Act has already been spent, other funds are supposed to roll out over the next few years. Trump has promised to rescind unspent funding, and he's called global warming a, quote, scam, unquote. Maynard, a marine resources management specialist at NOAA's Northeast Fisheries Science Center, said his group faced budget cuts before, including under the Biden administration, and found ways to keep the cooperative work moving forward. He expects the same will be true under the Trump administration. There's always a little bit of a scramble to pull in the dollars to keep the lights on, he said. Fishery manager O'Keefe said she's hoping to work with the Trump administration and said the impacts of climate change are too important to ignore and time is running out. My biggest worry is losing the industry, she said. We can't wait a decade because there won't be New England fishing industries left anymore. Our next story comes from the South China Sea. Massive chunk of coral reef destroyed by island-building rivals. Rivals in the South China Sea developing artificial islands to back up their claims have destroyed nearly 28.3 square kilometers of coral reefs. A US-based think tank said, with China responsible for the most damage followed by Vietnam. The Asia Maritime Transparency Initiative, or AMTI, analyzed island building activities of rival claimants including China, Vietnam, Malaysia, Taiwan, and the Philippines using commercial satellite imagery. Dredging and landfill had caused irreparable damage to the marine habitat, as well as long-term changes to the overall structure and health of reefs in the South China Sea, said the group, which is affiliated with the Center for Strategic and International Studies in Washington. China has caused the most reef destruction, having buried roughly 4,648 acres, 18.8 square kilometers of reef since 2013, AMTI said in a report, adding that Vietnam came second with approximately 2,362 acres, 9.5 square kilometers of reef, mostly in 2024. Government agencies in the two countries were not available for comment during the Lunar New Year holiday. The total area of damage increased by 800 acres, 3.2 square kilometers, from 6,200 acres, 25 square kilometers at the end of 2023. China and Vietnam are responsible for 65% and 33% of reef destruction, respectively, AMTI said. In December 2023 report, the group said that besides island building, giant clam harvesting by Chinese fishermen also damaged another 16,353 acres, 66.1 square kilometers of coral reef. According to AMTI, Manila planned to initiate a second legal challenge against Beijing over environmental destruction in what it calls the West Philippine Sea, or part of the South China Sea within the exclusive economic zone of the Philippines, where it has jurisdiction over natural resources in the water and the seabed. The Marcos administration, however, has yet to decide on a venue for the lawsuit. Malaysia, Taiwan, and the Philippines accounted for less than 3% of the damage, AMTI said. Papua New Guinea sits in the Coral Triangle, which is the center of marine biodiversity and is like the rainforests of the ocean, said National Geographic Pristine Seas Jen Cassell, Papua New Guinea expedition science lead, in his recently published field notes. The scientific group dove with their new Seaimagine sub, Argonauta, through the Papua New Guinea to learn more about its vast marine biodiversity and propel conservation efforts. This video shows some of the precious corals of the area that marine researchers are discovering and documenting as a result. Like a distant galaxy bursting with stars, gas, and dust, the siphonophore contains multitudes. According to the Smithsonian, a colonial organism from the phylum Cnidaria, the same phylum as jellyfish, this animal is made up of many genetically identical individuals called zooids. Each zooid has a job. Some feed, others manage motion or breed. Without each part performing its essential role, the whole would die. With about 10% of ocean life documented and described, understanding how animals reproduce, maintain genetic diversity, and survive is essential to effectively protecting and managing these extreme and fragile ecosystems in our global ocean. One of the primary goals of the expedition is to investigate ecosystem connectivity. Understanding the lives of animals and organisms has important implications for conservation. When a population is isolated, the risk of extinction grows dramatically. This expedition advances research on past ice sheet dynamics, its impact on Earth's climate, and Antarctica's biodiversity. Thank you so much for watching D2 News, Episode 6 on Marine Science and Oceanography. Hope you enjoyed. Please like, subscribe, and share. Make sure to bookmark our D2 News webpage. Make sure to follow us on Twitter and on LinkedIn, and make sure to stay tuned for the next episode of D2 Ocean News.